Hey everybody, welcome to Homework 1.8a. Today we are looking at some examples of what are called literal equations, and so I'm going to go over that, but I'm also, and this isn't anything new, you have seen this before, it just is going to look a little bit more complicated, okay? So we're starting with this table. The table shows the relationship between the base length and the area A of some parallelograms. All of the parallelograms have the same height. Base length is measured in inches and area is measured in square inches. Complete the table. All right. So what it's asking us to do here is to complete the table. So I'm looking for a pattern and I see that I have 1, 2, 3, and 3, 6, 9. Now seeing that, if I'm skip counting, I see that I'm moving up by multiples of 3, right? And so here I can see the pattern is that I'm multiplying by 3, multiplying b by 3 to get a, the area. So to do this, then I'm going to get 4.5 times 3 is 13.5. Okay, now it left one blank, so let's say we fill in, for example, 5. This would be 15, right? 36. Now to go the opposite way, we're going to do division, so divide by 3 will give us 12, and then 46.5, you might recognize it right away, but if we divide that by 3, we will get 15.5. Okay, so here it's wanting you to recognize that the pattern here is that we are multiplying by 3 to get the area. That means that the height, which it said is the same for all of them, is 3. Now it says decide whether each equation could represent the relationship between b and a. And so let's look, if we have b equals 3a, that would be 1, for using the first one as an example, 1 equals 3 times 3, which would equal 9. So that is not true. That does not work. B, if we have b equals a over 3, that would be 1 equals 3 over 3. That is true, so B does in fact work. You can try it on any of them. 15 divided by 3 is going to give us 5, right? And that is from this line, so that is going to work there. All right, the opposite then, area equals B divided by 3. Let's use an example of 9 equals 3 divided by 3. 3 divided by 3 is 1. That does not work, so that does not work here. And then A equals 3b. We have 3 equals 3 times 1, or 9 equals 3 times 3. That does in fact work, so D is also correct. All right, now this part right here is going over what literal equations are. So it says read carefully and then complete the work. So literal equations are ones in which there are multiple letters or variables. We see this a lot in science, especially physics, and then also in geometry. So you'll continue to see equations like this as you continue in your academic career. Often if you're solving for one of these variables, it's easier to change the equation to solve for that variable and then use that equation, right? Use the new equation that you've created. So an example is we have velocity equals distance over time. If, for example, we wanted to instead solve for distance, we can multiply both sides by t, and this operates the same way numbers do. So t divided by t is just 1, that's going to cancel out, and you'll be left with distance equals times your velocity. Time times your velocity. So we can treat equations with multiple variables the same way that we would treat them if they had the numbers, right? So if, for example, we're solving for x here, the first thing that I would want to do is get rid of this 4 and divide by 4 on both sides. So then 4 divided by 4 is 1. We're left with x plus y equals p divided by 4. Now if I want to get x by itself, I can subtract y. That's our inverse operation. And we'll get x equals p divided by 4 minus y. Okay? So again, you're treating those variables the same way you would treat them if they were numbers. All right, so this is then having you practice the application of that. So after a parade, a group of volunteers is helping to clean up a 2-mile stretch of road. The group decides to divide the length evenly. So let's imagine we have 2 miles, right? And we're going to divide it up and break it up so that each volunteer is responsible for cleaning up equal length sections. So we're dividing it up equally. Find the length of road section for each volunteer if the following numbers of volunteers. Be prepared to explain or show your reasoning. So if we have a 2-mile stretch of road and we have 8 volunteers, we're going to break it up 8 times. So 2 divided by 8 will give me 1/4, or 0.25 miles. All right, and so you're going to go through and do that for each one of these. 2 miles, and you can use your calculator if you want. 2 miles divided by 10 is 0.2 miles. Okay, if we have 25 volunteers, they're going to only have to clean up a very small portion of 0.08 miles. It's a very, very tiny section. And then 36 miles, even smaller, right? We're getting smaller and smaller here because we have more and more people to clean. They would only have to clean up 0.056, we'll round up. So very small section, right? Some feet of that mile. So it says, write an equation that would make it easy to find L, the length of the road section in miles for each volunteer, if there are N volunteers. So what we did is we took the 2 miles and we divided it by the number of volunteers. So if the number of volunteers is replaced with N, we did 2 divided by N gives us L, the length that we would need to clean up. So L equals 2 divided by N. Now it says find the number of volunteers if if each volunteer cleans up a section of the following lengths. So if each person cleans up 0.4 miles for a 2-mile stretch, how many volunteers did they need, right? So using this equation above, we have the length is 0.4, for example, in this first one, equals 2 divided by the number of people. All right, well, so to get that N, right, I can multiply both sides by N, and then this will cancel out. We'll get 0.4N equals 2, and then we can divide both sides by 0.4, right? So N, then it's asking you to find this here. N equals 2 divided by the length, or 2 divided by, in our first case, 0.4. So that makes it easy to solve for each of these above. So 2 divided by 0.4 is going to be 5. That means they had 5 volunteers. All right. And then for this next one, we have a fraction. Okay, so I know you love fractions, but you can do this as 2 equals 2 divided by 2/7. And when we divide by 2/7, N equals 2 times 7 over 2, right? We divide, we multiply by the reciprocal, or keep, change, flip. And so we changed to multiplication and we flipped. 2 divided by 2 is just going to be 1, and so this will be 7 volunteers. Now you can also prove that by 2 divided by 7, we get a decimal here, all right? And then you can do 2 divided by second answer, and that's going to give you 7. Remember that answer button helps us to find out using the answer that we got in the previous line. So either way, you're going to get 7. So you can play with those fractions or you can convert them to decimals. I would encourage you to play with fractions so that you get really good at them because they are really important. All right, so we have 0.125 miles. So 2 divided by 0.125, 16 people. And then here we have another fraction. So 2 divided by 6 over 45 equals 2 times 45 over 6. All right. Now, 2 is divisible, 6 is easily, can be divided by 2, so we end up with 3, right, if we reduce that. And so we have 45 divided by 3, which you might recognize immediately as 15. Okay, now again, if you wanted to, you can convert that into a decimal, and then we can say 2 divided by our answer, whoops, it's going to give us 15, okay? Either way, you're going to get 15. And again, that equation then, if we just play with it the same way we would play with numbers, we can solve for N instead of solving for L. All right, tank A. So we have a water tank. I find it helpful to kind of like draw a little picture. And it has 124 liters of water in it. And it is filling up with more water. So this should be increasing at a rate of 9 liters per minute. So plus 9 liters per minute. All right, so that's our equation. The liters of water equals 124 plus 9m. This is our starting amount, and then this is how much it's increasing. It says how many liters of water are in tank A after the following amounts of time have passed. So after 4 minutes, well, we're going to say 9 times 4 is 36, plus 124 is going to give you 160, so there'll be 160 liters. After 80 seconds, now 80 seconds out of 60 seconds, right, because this is in minutes, 80 seconds over 60 seconds, if you reduce that in fraction terms, it's going to be 4/3 or 1 1/3. And so we can do 4/3 times 9. 9 times 4/3. This will end up being 12. So 124 plus 12 is going to give you 136. Okay. Now, again, you can convert that 4 divided by 3. It's going to give you that really lovely decimal. And then you can go ahead and multiply times 9 plus 124. And you're still going to get 136. So you can use the fraction or you can use it as decimal. And then m minutes, that was kind of something I did naturally as I looked at the problem. So L equals 124 plus 9 times the number of minutes. Now the opposite, how many minutes have passed P when tank A contains the following amounts of water. So if L is 151 and we start with 124 still plus 9 liters per minute, if we now want to solve for minutes, right, we're going to use our inverse operations and we're going to subtract 124 from both sides first. That will cancel out. You have 151 minus 124 is 27 equals 9m. That's what's remaining on the other side. Divide both sides by 9. We get m equals 3. Right? So after 3 minutes, we'll have 151 liters. Right? So you're doing that same process for all of these. Right? You're starting with what is the end value that we end up with in the tank, and then how long does it take to get there. So in looking at this equation, right, when we get down to this P liters part, if instead we wanted to solve for how many times, how long this has passed, right, we have P liters equals 124, oops, that should be a 2, excuse me, 124 plus 9m. So if we want to solve for m, we can very simply do P minus 124. We subtract 124 from both sides equals 9m. And then we need to divide by 9. So if you're looking for the equation to use, you have minutes equals your end amount of liters, P minus 124, your starting amount of liters, divided by 9, how many liters per minute it's growing. So if we try that then, we can do 191.5 minus 124 divided by 9 is 7.5. This gives us how many minutes it would take to get to 191.5 liters. All right, try that with 270. You can do that on your own. Again, you're plugging that in here for P now that you have that equation and see what you get. All right, tank B is the opposite situation. It's initially contained 80 liters. So we have our tank, it contains 80 liters, and it's draining, so it's going down. So here, I'm going to be thinking about 80 liters of water minus 2.5 per minute, right, equals the number of liters remaining. And so here, it's asking you to do T minutes, so you could place that M with a T, but you're going to do 2.5 times 30 and then subtract that from 80. So 80 minus 75 is 5. So after 30 seconds, there's only 5 liters left. Oh, actually, I'm so sorry. That would be 30 minutes. This is 30 seconds. So it's saying per minute. So this is actually 1/2 of a minute. So 30 divided by 60, right? 30 seconds out of 60 seconds gives us minutes. So that's 1/2. This is why we do things carefully here, okay? So 1/2, so 2.5 times 0.5 times a half is 1.25. So 80 minus 1.25 gives us 78.75. So after only 30 seconds, and that makes sense, we can look at this because it's draining at 2.5 liters per minute. It's only lost 1.25 liters, a very small amount there. All right, that makes a lot more sense. I was like, that's a very small number. Here we go. Okay, and then if we have 7 minutes here, we have 80 minus 2.5 times 7 minutes. And so 2.5 times 7 gives us 17.5. 80 minus our answer is going to be 62.5. So after 7 minutes, we'll be down quite a bit. And then T, again, we're just replacing our minutes here with T, okay? Equals, we'll say, the liters left. All right, now it says for how many minutes, so it wants us to work opposite in the equation. So again, I would suggest that you start by creating this equation because that'll make it easier for you to plug things in. So if we're talking about 80 minus 2.5 m equals v liters, right? And then if we want to solve for, or actually it says t, if we want to solve for the minutes now, instead of solving for the liters, we can go ahead and let's start by, we're going to subtract 80 from both sides. All right, so 80 minus 80 is 0. We get negative 2.5 t equals v minus 80. And then we can go ahead and divide both sides by negative 2.5. And now we have the time that that's going to take. All right, so we can put in our liters here, 75 minus 80, and then divide by negative 2.5 gives us 2. So we'll be down to 75 liters after 2 minutes. All right, so again, solving for this first and using that literal equation can make this faster. So you can try B and C, plug those in and see what you get, right? If we do 32.5 minus 80, and then divide by negative 2.5, we get 19, okay? So again, after 19 minutes, we will have lost much more water. All right, so you can check to see if it makes sense given the amount of time. Should that be how much water you've lost or gained depending on the situation. All right, so you do C completely on your own because I said you had to do B, but then I showed you how to do it. You can use your calculator for these. That will make it a little bit faster. And again, you can look at things in terms of fractions or in terms of decimals. Okay, so your code word for today is barrel, B-A-R-R-E-L, since we're talking about water tanks. Barrel. Okay, put that at the top of your paper, get extra credit. Have a wonderful evening, and I'll see you tomorrow.